Good morning, sir. My name is Arvind. I am from Mechanical Engineering, third BTech, second semester. Today, my topic is about film-wise condenser and drop-wise condenser. Introduction to condensation. Introduction to condensation. Condensation is the process of vapor turning into liquid when it cools down. Plays a crucial role in various engineering and industrial applications. Understanding different types of condensation helps optimize heat transfer process. Overview of film-wise condensation. Film-wise condensation occurs when a continuous film of liquid from a surface. This film acts as thermal resistance affecting heat transfer efficiency. It is the more common type of condensation observed in many systems. Mechanism of film-wise condensation. Vapor vapor condenses uniformly over the surface creating a liquid film that thickens over time. Heat transfer occurs through the film which can insulate the surface. The film thickness influence influence the rate at which heat is transferred away. Characteristics of film-wise condensation. The liquid film remains relatively stable and covers the entire surface area. The heat transfer coefficient is typically lower due to the thermal resistance of the film. It is often observed on smooth, clean surface with high wettability. Advantages of film-wise condensation. It is earlier to model and analyze mathematically, suitable for applications where uniform coverage is desired. Less prone to sudden fluctuations compared to dropwise condensation. Disadvantages of film-wise condensation. Lower heat transfer rates due to the insulating liquid film can lead to large surface temperature differences. Difficult to maintain high efficiency in heat exchangers with this mode. Drop and film-wise condensation apparatus. Aim to determine the inside and outside heat transfer coefficient of film-wise and drop-wise condenser. To study the drop-wise and film-wise condenser phenomena, apparatus, film-wise and drop-wise condenser enclosed in a glass tube with flow control valves, steam generator with heating elements, detail temperature indicator with selector switch. The process involving phase change like boiling and condensation and also very important in engineering practice. Boilers and condensers are essential components to modern the thermal power plants. So there are evaporators and condenser in vapor compression, refrigerant cycles. The phenomena of boiling heat transfer has also been successfully used in the cooling of nuclear reactants and rocket motors, where the energy dissipation rate and extremely large in order to be dropwise and film-wise condensation. Overview of dropwise condensation. Dropwise condensation involves the formation of discrete liquid droplets on the surface. These droplets grow and eventually roll off the surface. It is generally results in higher heat transfer rates compared to film-wise condensation. Dropwise versus film-wise. The main difference between dropwise condensation versus film-wise condensation is that dropwise condensation the vapor condensed in the form of droplets on the surface of the condenser, while in the film-wise condensation the vapors are condensed in the form of thin film when wets the surface, resulting in an lowering or the rate of the heat transfer. Mechanism of dropwise condensation. Dropwise condense onto the surface imperfections, forming droplets rather than a film. Droplets grow in size as more vapor condenses onto them. When they become large enough, gravity causes the droplets to detach and fall away. Characteristics of dropwise condenser. Surface remains relatively dry between droplets, reducing these resistance. The process is dynamic with continuous droplets from and removal. It requires specific surface properties to promote droplet forming and scheduling. Advantage of dropwise condenser. Significantly higher heat transfer coefficient compared to the film-wise condensation, improved efficiency in heat exchangers and condensers, required liquid film buildup, minimizing insulation effects. Disadvantage of dropwise condensation. Maintaining the surface in dropwise condensation mode can be challenging. Surface treatments or coating are often required to sustain dropwise behavior. It may be suitable for all operating conditions or fluids. Factor influencing condensation mode: surface wettability and roughness play a crucial role in determining the condensation type. Temperature and vapor pressure influence droplets information and film stability. Surface coatings can be used to promote either filmwise or dropwise condensation. Applications of filmwise condensation: used in systems where simplicity and uniform coverages are prioritized. Suitable for systems with high fouling tendencies or where surface maintenance is difficult. Application of dropwise condensation. Summary and conclusions. Understanding this process allows engineering to design more efficient thermal systems. Both films are dropwise and they have distinct mechanism, advantages and limitations. Thank you.